Welcome to your first video of second semester of Algebra 2. For those of you that are new to my flipped classroom, there's a couple of things I want to go through before we dive into the material. First thing, while you're watching this video, my expectation, you should have your notepad in front of you, something to write with, because you should be taking every note that I take, writing down everything that I do, making side notes of everything that I say, and then of course also have your calculator out with you because you need to be doing the calculations with me. Don't just take my word for it and watch me. You need to be involved in this process and make sure you are following along and engaged in the note taking. As for the notes themselves, you'll notice every one of my notes will tell you which section it is, what the name of the section is, and then we always have a learning target, our goal for the day of what I want you to get out of these notes. For these first notes, it should be really quick and sweet. We're just talking about simplifying expressions using rules of exponents. This is just kind of a precursor to the chapter, a little review of exponential algebra to make sure that you're set for the skills you're going to need throughout this sixth chapter. If you notice right here, we have a little table here. What this is doing for you, this is summarizing all the rules of exponents that you learned 2 years ago back in exponential algebra. Okay, learning how negative exponents will flip a fraction. When you're multiplying two things, you add the exponents. When you're dividing two things, you subtract the exponents. All those basic rules are laid out for you right there if you ever need to reference them or review them as you're stepping through this process. I just wanted you to have them. I'm not going to go through each of them individually. You'll kind of see them throughout the examples that I'm going to do. The next thing you'll see, I love step-by-step processes, okay? I'm a very algorithmic thinker. I want to have a process. I want to know exactly what to do in what order to get me to the answer. So a lot of times in my notes, you'll notice that's how I present them to you. If there's a process I want you to know, I will label them out for you in order so you can always go back and reference them. I may not talk through each step as I do it, but it's more of a reference point of if you ever get stuck in the process in the middle of an example, you can go back and see what was I doing at that point, okay? So here is a process that if you always do this step-by-step process, it'll always get you to the answer when you're simplifying expressions using rules of exponents. So I'm just going to go and dive into the first example. And again, if you ever wonder why I'm doing what I'm doing, what point of or what step I'm at, go and reference those steps 1, 2, and 3. So for this first one, when you're simply multiplying two things together, the things I want you to remember, if there's numbers, so here 5 times negative 3, you just multiply those numbers together. 5 times negative 3 gives me a negative 15. Then I focus on the exponents. So now I have a to the 3 and a to the negative 4. And you know when you're multiplying things with like bases, you end up adding the exponents. So 3 plus a negative 4 is going to give me an exponent of negative 1. The other thing you should remember is when you have a negative exponent, you can never answer something and leave it as a negative exponent. You always need to flip it, okay? So that 15, that ends up down in the bottom, okay? And when you do that, there's a 1 you leave up top. If you ever send everything downward, there's just a 1 up there. And then, of course, you still need to make sure you include this original negative. Okay, a number being negative doesn't mean you move it. It's the negative exponent that moves, okay? Something to watch out for because I've seen a lot of mistakes with that. All right, our next one. Now this one, we have some simplifying to do within the parenthesis first. Now, in this one, I'm actually going to deal with this negative exponent right away, okay? That x has a negative exponent. So what I'm going to do is I'm going to send that x downward right away. Get an x to the 3 down in the bottom, okay? So unless that negative exponent is immediately combining with something like it was in the first example, I would just move it right away. Okay, get every exponent to be positive before you move on in the process. So now that I've done that, now I'm going to take this 2 here, this squared. Now that I've simplified within the parenthesis, now I'm going to apply that square to everything inside the parenthesis. Okay, so negative 4 squared. Well, negative 4 squared is a positive 16. Y to the 5th squared. This is an example of our power of a power rule. And if you remember, whenever you have a power of a power, you multiply those exponents. So you get a 10. X to the 3rd to the 2nd, well, that's another power of a power. 3 times 2 gives us 6. And that's going to be our final answer. For the next one, again, I see a negative exponent within the parenthesis and it's not able to combine with anything right away. So I'm going to clean up that parenthesis. So I'm going to have the 2r cubed, and I'm going to move that t to the 5th down so it can have a positive exponent right away. Okay, I'm going to take care of that negative exponent. Well, now I notice something else. Now I notice that the entire parenthesis has a negative exponent. When an entire parenthesis has a negative exponent, what you do is you flip everything in that parenthesis. So what's going to happen is I'm going to flip that up top and all of this down. Okay, that's how you clear up a negative when it's applying to the whole parenthesis. You flip the entire fraction. Everything inside ends up getting flipped. Okay, now I'm free to apply that 3 throughout. So now power of a power says that becomes a t to the 15. 2 to the 3rd. 2 times 2 times 2 gives me 8. R to the 3rd to the 3rd. Power of a power again. And then I still have that stuff sitting outside. All right, and the final step. Now that I've taken care of everything inside the parenthesis, now I'm ready to combine it with the things outside the parenthesis. Well, t to the 15th times t to the 1st. Well, 15 plus 1 leaves me with a t to the 16. The 8 doesn't have anything it's combining with. And now the r's. I have an r squared on top and an r to the 9 on the bottom. And if you remember, when you're dividing, you end up subtracting the exponents. So 2 minus 9 is going to give me a negative 7. What that negative 7 tells me is right away, I can just toss it on the bottom to deal with that negative. Okay, that's how you can more easily deal with division. Is if you're subtracting, you end up with a negative exponent, just put it on the bottom right away, and then you don't have to deal with it anymore beyond that. And that is going to be the end of that problem. Now for the next one. So here, dealing with this fraction, the 4 has nothing that it's doing, nothing it's combining with. But the a's, so I have an a to the 1st divided by an a to the 5th. Well, division, again, equates to subtracting the exponents. 1 minus 5 leaves me with a negative 4. And like I just said in the previous example, if you end up with a negative exponent, just put it on the bottom right away, because then you don't have to deal with it. You don't have to worry about it. Now for the b's, b to the 6 divided by b to the 1st. 6 minus 1 leaves me with 5. So I'm going to plop that on top. C cubed divided by c cubed. If you ever have the same thing on the top and the bottom, it just cancels off, okay? So I don't have any c's left in my answer at all. It's just 4b to the 5th divided by a to the 4th. And for our last example, so here I'm going to clean up my fraction first, okay? So I notice a lot of things that can end up combining. The 3 and the 5 don't have any common factors. That part isn't going to reduce for me. But x squared divided by x to the 1st. 2 minus 1 leaves me with an x to the 1st, but obviously I don't have to show the first power. I can just leave it as an x. Y to the 1st divided by y squared. Now this is one of those cases where that negative, okay, that would really mean shifting it up to the top, right? Remember, a negative exponent means you shift it up. So basically it's going to combine with the 1 that's already on top. So you have 2 that are coming up to combine with the 1 that's already up there. So that's going to give you a total of 3 when you make that shift, when you shove it up. Now, z to the 5th divided by z to the 2nd. Again, division equates to subtraction. 5 minus 2 leaves me with a z to the 3rd. So now that I've cleaned up everything inside the fraction, or inside the parentheses, I apologize, now I'm ready to apply the power. So I'm going to apply that squared to everything. 3 squared gives me 9. X squared is, just like I said, x squared. Y to the 3rd squared. So again, power of a power, 3 times 2 leaves me with 6. Y to the 3rd to the 2nd, again, power of a power, 3 times 2 leaves me 6. 5 squared is going to leave me with 25. All right, so thank you for watching this for me. Again, I hope that this one wasn't too painful for you, just quick and sweet to show you how this flipped classroom works, how to watch these videos, okay? So thank you so much for joining me. And now after this, you're always going to have a practice sheet that you receive in class to work on for me. So be prepared after we're done with this video, you will get a practice worksheet, so now you can practice these skills without me watching.